Hello everyone. Once again, we will hear in the chapter Polynomials to solve the relative problems which used to come there in the board examinations. Very important questions are there. So first question, you can see here, if alpha and beta are the roots of a quadratic polynomial, x square minus 3x minus 4, then find the values of these. This is this. So you can see that alpha, beta here in three problems, three questions. You can see here. But that if you'll get the value of alpha and beta, then you'll put here in the respective places, simplify it, you'll get the solution. Or to do that one, so we will do here, the polynomial that we have is x square minus 3x minus 4. So to find it out the roots, let this px is equals to 0, that means x square minus 3x minus 4 is equals to 0. You can say that using the middle term splitting, x square minus this minus 3, that means 3 should be splitted into two parts. So here is plus into minus minus sign. By subtracting two numbers we are supposed to get 3, but by the product of that two numbers we are supposed to get the 4. So that is definitely 4 and 1, because 1 4s are 4, 4 minus 1 is 3. So x square minus 4x plus x minus 4 is equals to 0. So look at here, if we'll take x as a common, here will be x minus 4, and if we'll take 1 as a common, he will be getting here x minus 4 once again. But if there is, okay, suppose there is no common, it means that 1 is common, that is universal. X minus 4 will be in one of the bracket, and in another one you can see that x plus 1, that is equals to 0. If we'll do that either or, because product of the two numbers you are going to get 0, which implies that one of the numbers should be 0. So here you can say that the value of x is 4 and another value of x is minus 1. So we have alpha and beta. So I'm telling you that one of the value is 4 and another value is minus 1 that we have obtained by using this middle term splitting. So in this problem, we can say that alpha is equals to 4 and beta is equals to minus 1. So we will use this one there in their respective places and we will calculate the values. So first one is 1 by alpha plus 1 by beta minus 2 alpha beta. So one of the root that you can see, one of the root is 4 and another root is minus 1. 1 by 4 plus 1 by, in place of beta we'll put minus 1, minus 2 times 4 into minus 1. So it gives us 1 by 4 minus 1 plus 2 4s are 8. So 1 by 4 minus 1 plus 8, it gives us plus 7. So easy way to calculate this type of mixed fractions, 4 7s are 28 plus 1, 29 divided by 4. This is the solution of first. And second one, this is number 1. And second, that we have the problem 1 by alpha minus 1 by beta. 1 by alpha minus 1 by beta. Again 1 by, in place of alpha that you can see that 4 minus, in place of beta there is minus 1. So we can use that 1 by 4 minus into minus plus 1. 4 1s are 4 plus 1, 5 divided by 4. This is the solution of second one. Third one that you can see, is alpha square plus beta square. We'll solve here. Alpha square plus beta square, that gives us 4 in place of alpha 4 square plus beta is minus 1 square. 4 4s are 16 plus minus square, that gives us plus. I already have told you, negative to the power even number is positive, negative to the power odd number is negative. So it gives us 1 here. So 16 plus 1 is 17. So this is one of the most important question, that used to come frequently there in the board examination. So what we have here is alpha and beta are the roots that already has given to us. So we use the middle term splitting here and we obtain the solution. Then after we have put their respective values in their respective places. But what will you do if the roots, that means by using middle term splitting, the roots are not obtaining clearly, directly? So for that we will solve one of the problem. So we will see one problem, px x square, you can say that minus 2x plus let it be 6. Simple idea is that here you can see that product of first and last is 6, and 6 has factors 2 multiplied by 3 or 6 ones are 6. In these two cases, any two of them by adding we are not going to get 2. So it means that middle term splitting is not possible. Now I am telling you, for the existence of real roots, for the existence of the real roots in a quadratic equation, there is one part we used to say that the discriminant, with respect to the discriminant, we can say whether directly the real roots exist or not for the quadratic polynomials or quadratic equations. That we will discuss in the next class. So here we will see first whether we can obtain the value of alpha and beta or not. That is for sure. By factorization we cannot get. That is for sure. So what to do in this case? But the question already they have given us. We'll solve one of the problem. 1 by alpha plus 1 by beta minus 2 alpha beta. We will solve this one. In the previous case, you can see here, once we have the value of alpha and beta, so we have used that directly to obtain this value. Now here in this problem, what is there? If we can get the value of alpha and beta, then it will be easy. We can put here and we can solve it. But the fact is that in this problem, we cannot get it. So for that, what we need to do? For this, alpha and beta are the roots of, let it be, of px. We'll say that px, polynomial in the variable x. So therefore, we have one weapon. That is the relationship between roots and coefficients. So sum of the roots is minus b by a. So you can see that minus this b is the coefficient of x, that is minus of minus 2 divided by a is 1. So this is equals to 2. And product of the roots is c by a. C is the constant, purely constant, that is 6. In place of a, that is coefficient of x square is 1. So it gives us 6. Clear, right? Sum of the roots minus b by a, minus is already there, but in place of b also there is minus 2. If it is not clear, just compare like this: x square minus 2x plus 6 with ax square plus bx plus c. Just look at here, in place of a there is 1, in place of b there is minus 2, in place of c there is 6. So we have used the same value. So what we have here, sum and the product of the roots are there. Now we will solve this. But how to solve it? See this one, we will be doing here. There is 1 by alpha, 1 by beta. But if you see this two, if you take the LCM, alpha into beta will be the LCM. So I already have told you, for the calculation of the fractions, you can go with the cross multiplication. Beta into 1 is beta, plus alpha into 1 is alpha. Minus 2 alpha beta is there. If you'll see carefully, now you can obtain that sum of the roots are also there, product of the roots are also there. So sum of the roots in place of alpha plus beta, we can say that we can write 2. Product of the roots, we can write it down 6. Minus 2 into, you can see that product of the roots in place of alpha into beta, we can say that we can write 6. 2 by 6, 2 ones are 2, 2 threes are 6. Minus 2 6 are 12. Once again this is a mixed fraction with a minus sign. What we'll do is that 3 multiplied with 12 is 36, and 1 minus 36 is, you can write it down here, 1 minus 36, that gives us minus 35 divided by 3. If you want to write in a mixed fraction, you can say that minus 3, how much are 35? 3 cannot divide it, but 3 11s are 33, 34, 35, 2 divided by 3. So this is the solution, and this is also one of the option. If you cannot get the value of alpha and beta, it means that if you cannot obtain the roots of a quadratic polynomial, then you can follow this one, find it out, sum of the roots and the product of the roots. But for that, just look at there how to simplify it. You have to convert whatever problem will be given to us, that should be converted in terms of sum and the product. Then the solution will be very easy. So this is also one of the problem. Every time you are not going to get the roots using middle term splitting or using quadratic formula, that we'll discuss later. Now Next question that you can see here on the board from the same chapter, polynomials. Now look at here. Sum and the product of the roots have a relationship with the coefficients in a quadratic polynomial, but you just see the different forms of the equations. In the previous video also, in the previous class also, we have solved some of the equations there related to the same chapter. Here also you can see that just see the types of the equation, different forms of the equations, but the fact is that sum and product every time that will be mentioned here. Now look at here in this question, find a quadratic polynomial. So here you are supposed to get a quadratic polynomial, but whose roots are the double of the roots of a quadratic polynomial. This first we will solve with one of the method. I will say that this is method number 1. That in this method what we'll do is first find it out the roots. We'll find it out the roots of this. Now before to find the roots, I am again explaining the problem for you. You are supposed to find it out a quadratic polynomial whose roots are double the roots of this. Suppose you have the roots of this quadratic polynomial is, let's say, 2 and let's say 5, only for example. Now what you are supposed to find it out is, you need to find it out a quadratic polynomial whose roots are double of this. What is the double of 2? 4. What will be the double of 5? 10. So by using roots as 4 and 10, we are supposed to obtain the quadratic polynomial. If, this is only if part. That question wants here. First of all, what we will do is we will find it out. First we will find it out the roots. Don't say that 2 and 5 are the roots of this. That is only for one of the condition. Example. Let px is equals to 0. So x square plus 2x plus 4 is equals to 0. And we just want to use the middle term splitting, whether it is possible or not. Till here it seems it is possible. Now look at here. 1 into 4 is there. 4 1s are 4. The factors of 4 are 4 1s are 4 or 2 2s are 4. Here is plus into plus plus. Do we have any pair whose sum is 2? No. So we cannot use this. We cannot obtain the roots here. So once we don't have any method to find it out the roots for this quadratic polynomial, then this method number 1 is invalid. We cannot obtain it. So what is then the next method? I'll explain you what that method number 1 was in the another question. Let me first solve this one. Method number 2. Px, that is given to us, x square plus 2x plus 4. Now we will use the same, the sum and the product, that relationship with the coefficient. First we will compare x square plus 2x plus 4 with ax square plus bx plus c. So the value of a is 1, value of b is 2, value of c is 4. That we have, and let alpha and beta are the roots of px, the given polynomial. Then we can say that sum of the roots is minus b divided by a, minus in place of b there is 2 divided by 1, that is equals to minus 2, and product of the roots that we have c divided by a, you can see that in place of c there is 4 divided by 1, that is equals to 4. That here you can see that sum of the roots, what we have, sum of the roots as minus 2 and product of the roots is 4. But this is of this polynomial x square plus 2x plus 4. Now what we need to do? We need to find it out a quadratic polynomial whose roots are double of this, double of alpha and beta. So what is the double of alpha and beta? The double of alpha will be 2 alpha and double of beta will be 2 beta. So we need to obtain a quadratic polynomial whose roots are 2 alpha and 2 beta. So the quadratic polynomial is, what will be the quadratic polynomial? X square minus sum of the roots into x plus product of the roots. X square minus, in place of sum we can write 2 alpha plus 2 beta, because for us the solution of the problem, solution of this problem, that quadratic whose roots are double, is here in place of roots of that quadratic polynomial we need to write it down double of the roots of this polynomial. So into x plus product of the roots means 2 alpha product with the 2 beta. X square, do we have any common here? Yes, 2 as a common, alpha plus beta into x, and here you can see that 2 2s are 4 alpha beta. Now what is the value of sum of the roots? Minus 2. In place of sum of the roots we'll put that minus 2 into x plus, you just see that what is there in place of product of the roots, that is 4, so 4 multiplied with 4. So this is equals to x square minus into minus plus 2 2s are 4x plus 16. This is a quadratic polynomial whose roots are double of the roots of the quadratic polynomial x square plus 2x plus 4. So this is the solution. Now I already have told you that under what condition that we have the method number 1. We have solved here method number 2. We started with the method number 1. The problem is that we cannot get the roots here directly. But if there is slight change or there is a different problem for the same question, now we'll take one example, same type of question. Px, the given polynomial is x square, let's say plus 4x minus plus 3. Let's say x square plus 4x plus 3. This is one of the quadratic polynomial that is given. This is given polynomial, and we need to find it out a quadratic polynomial whose roots are double of this. Suppose it has roots alpha and beta, then we need to find it out the quadratic polynomial whose roots are 2 alpha and 2 beta. And here the solution will be, or the quadratic polynomial will be, x square minus sum of the roots into x plus product of the roots that we already have seen. Once we'll get the value of alpha and beta here by middle term splitting or factorization, we will put it here, but the solution will be here x square minus sum of the root means 2 alpha plus 2 beta into x plus product of the roots means 2 alpha into 2 beta. That will be the solution for that. But here we just want to use the method number 1. Now here it seems it is possible for the middle term splitting. Let x square plus 4x plus 3 is equals to 0. X square plus 4 should be split into 2 parts, but that 2 parts should have a product 3. So we can say that 3 plus 1. So x square plus 3 into x is 3x plus 1 into x, x plus 3 is equals to 0. If x is a common, you'll have that x plus 3. And if 1 as a common, if there is nothing as a common, every time I am telling you that, there you can take 1 as a common. So x plus 3 multiplied with x plus 1, which gives is equals to 0. If you'll do the either or part, here you know that why we are using this one, because product of any two number is 0, that should be from if one of the number is 0, or both should be 0. So here you can see that the value of x is minus 3, and from here the value of x is minus 1. So this we can take as alpha, this can be taken as beta. So we have the value of alpha and beta. Now we already have the solution for this. These all are the solutions, but actual answer we can say that the quadratic polynomial is, we will put here x square minus 2 into what is there in place of alpha? Minus 3 plus 2 into, in place of beta, minus 1, x plus 2 2s are 4 into, in place of alpha is minus 3 and in place of beta is minus 1. Look at here. X square minus 2 in place of alpha is minus 3, in place of beta is minus 1, x plus 4 times in place of alpha minus 3, in place of beta minus 1. And it is not necessary that always the first value that you should take as alpha. No need to do that one. You can take this as alpha and this one is beta also. So x square minus, you can see that plus into minus, minus 2 3s are 6, plus into minus, minus 2 into x, plus into minus, minus into minus, plus 4 3s are 12. So we are about to get the solution. X square minus, minus 6 minus 2, it gives us minus 8. Same sign will be added and opposite sign will be subtracted. Plus 12. So the actual solution is minus into minus plus 8x plus 12. So this is the problem where we can find it out. Its solution as x square plus 8x plus 12. It means that this is a quadratic polynomial whose roots are double the roots of this quadratic polynomial. So this is method number 1. If method number 1 is not possible, it means that if factorization is not possible, then you should follow the method number 2. And method number 2 is direct to get the relationship between sum and product of the roots with their coefficients and put it there in the respective places. Next question. If alpha and beta are the roots of a quadratic polynomial, this and alpha minus beta is 4, then find the values of k. Solution. Number 1, you can say that px is equals to x square minus 3x minus k. So alpha and beta are the roots. Here, sum of the roots is minus b by a. Look at here. Do we have to compare it? Let's compare it with this ax square plus bx plus c. Compare it. In place of b you can find it out, minus 3. In place of a there is 1 and it gives us 3. This is sum of the roots. Product of the roots, c divided by a. In place of c what is there? Minus k divided by 1, which is equals to minus k. Now look at here. Sum of the roots, that you have 3. Product of the roots, that is minus k. And since given, another given section that we have is alpha minus beta is equals to 4. This is one of the given section. Now we are supposed to get the value of k. Sum of the roots 3, product minus k. We need to obtain the value of k. Now there are many ways. I am telling you first one of the most easy way, and this will be applicable in some of the problems only, not in all. You can see that sum of the roots that we have 3 and difference of the roots is 4. These two are linear equations in 2 variables, so we can use one of the method, either substitution or elimination, to get the value of alpha and beta. Let's go with this addition. I will tell you this in details in the next class. Beta beta will be out. 2 alpha is equals to 4 plus 3 is 7. So the value of alpha is 7 divided by 2. Give this. Similarly, if you'll put in one of the equation means let it be 1, let it be 2. And 1 says that, here I'll write it down here, 1 is sum of the roots is 3, that means alpha plus beta. Alpha is 7 by 2 plus beta is equals to 3. So beta will be 3 minus 7 by 2. Now look at here. 2 3s are 6. 6 minus 7 is minus 1 by 2. So we have the value of beta also. So beta is minus 1 by 2. So look at here, the value of alpha is 7 by 2, beta is minus 1 by 2. And you know that product of the roots is minus k. That k should be obtained here. The question is asking this. So alpha plus beta is equals to minus k, and in place of alpha 7 divided by 2 multiplied by, in place of beta minus 1 by 2 is equals to minus k, and it implies 7 ones are minus, 7 ones are 7, 2 2s are 4 is equals to minus k. Minus can be removed from both the sides, that means multiplying both sides by minus. So the value of k is 7 divided by 4. This is one of the way to solve the problem. So we will use the another method. Here, by using elimination method, we obtain the value of alpha and beta and we got this solution. Next, what we'll do is, here sum of the roots as 3. Product of the roots is minus k. And difference of the root as 4. Now look at here. We have one of the method to obtain this. We have one relationship with this 3. Alpha plus beta whole square is equals to alpha minus beta whole square plus 4 alpha beta that we have. Now we will put these values. It means that a plus b whole square is a minus b whole square plus 4ab. Alpha plus beta 3 square is equals to alpha minus beta 4 square plus 4 times alpha into beta is minus k. So 3 square is 9, 4 square is 16 plus into minus, yes, this is minus 4k. Take this 4k to this side, it will be 4k minus 4k, this will be plus 4k, 16 minus 9. You can see that 4k is equals to 16 minus 9 is 7. So the value of k is 7 by 4. With the another method also, we have seen that the value of k is 7 by 4. By using this method also, we got the same solution. So this is also one of the most important question. Always you try to find it out the best way and easy way to solve the problem. For that, you should understand the problem first. These are the problems that we have discussed here in the chapter Polynomials. These are the most relevant and repeated questions in CBSE class and board examination. So keep watching and keep practicing these type of problems, because you may get the same question there in the board examination. But the fact is that always there is second option to solve the problem, but you should understand the problem first. Right? Then which method can be applied and which will be the easiest way to solve the problems that you need to use there. Because more you practice, more you learn. Every time used to tell you is that whenever you will practice more, you will find it out the best and easiest way to solve each and every problem in mathematics. So telling you again, keep practicing, keep learning. We'll meet in the next video. Thank you.